Let's use our exponent rules to simplify a few expressions. The first couple of expressions they ask us to simplify, notice that we're multiplying and we have the same base. As long as our base is the same, the rule for multiplying with exponents is to keep this base the same, the base will never change, and then we're going to add up our exponents. So negative 8 plus 4 gets us an exponent of negative 4 once we add those together. So when bases multiply and are the same, exponents add. Now we don't want to have negative exponents in our answers, so we also came up with a rule, I call it the elevator trick, for changing a negative exponent into something positive. And what we're going to do is send that base with its exponent either up or down on the elevator. In other words, moving it to the top or bottom of a fraction. So once again, our base will not change. So I'm going to move the negative 4 to the bottom, or the negative 2 to the bottom, but that exponent will then become a positive 4. Now we can't have a numerator with nothing in it, so if that's the case, or everything got moved to the denominator of the fraction, make sure you throw a 1 in the top of that. So my simplified expression is going to be 1 over negative 2 in parentheses to the 4th power. If you want to actually work that out, go for it. Next up is the same idea. So base is the same and it's being multiplied together. So my rule is to add the exponents. So I end up with 3 to the negative 5th. And once again, we can't have a negative exponent. So we're going to move that down to the bottom of a fraction to turn it into 3 to the positive fifths. And once again, you can't have nothing in the top of the fraction, so throw a 1 up there. So 1 over 3 to the 5th. And again, if you want to work it out, go for it. Next rule we're going to take a look at is when we have a power raised to a power. In this case, our rule is to multiply the exponent. So I'm going to get 2 to the 12th power once I multiply those exponents together. Work it out if you want to, otherwise leave it the same. And then next up, I've got 5 to the 0 to the 3rd. A power to a power, the rule is to multiply, so I get 5 to the 0. Now 0 is a special exponent. Anything raised to the 0 power, except for 0, is always equal to 1. So that's just going to become a 1. Now some people think of this problem differently. They see 5 to the 0 right away, and they say, well, that's 1. And then they figure out what 1 to the 3rd is. Well, 1 times 1 times 1 is also 1. So you're going to see a few ways to solve these problems, which is totally fine to do. The bottom row has fractions raised to a power. As long as we have only a single term inside the parentheses, no plus or minus signs, that would indicate more than one term, I'm allowed to distribute the exponent. As soon as you see more than one term, it will not work. So if there's any plus or minus signs in your parentheses, you can't distribute like we just did. So in this case, let's just distribute to the top, and the rule is a power to a power. We just talked about that rule was to multiply, so 3 to the 10th, and then over 3 to the 6th once I multiply those exponents. Well, now my bases are being divided, and again, the bases have to match for this to work. My rule is to subtract the exponents when bases are being divided, so I end up with 3 to the 4th power. And again, there's a few other ways to do it. Some people would look in here and want to simplify first. By subtracting exponents, that would get them 3 to the 2nd power. Make sure you always do the top minus the bottom, by the way, when you subtract, and then simplifying that would still get you 3 to the 4th power with an exponent raised to another exponent. All right, and lastly, on this screen, once again, there's only one term in there, so I'm probably just going to start by distributing my exponent. So 10 to the negative 4th when I multiply, over 10 to the negative 8th. Now, neither of those are in the spot we want them to be in, so what I'll need to do is actually send both of them on the elevator. The one on the top will move to the bottom, the one on the bottom will move to the top, so they'll switch and become 10 to the 8th. Over 10 to the 4th power now that I've changed their signs, and once again, I'm going to divide my bases, which means I'm going to subtract my exponent, so 10 to the 4th power. So right now some of you may be thinking, well, these exponent rules, that's all great, but I'm just going to type in my calculator and get an answer anyway. So what we decided to do was, well, let's take away the ability to use a calculator and give you some of these problems that have variables in them. The good news is our exponent rules still work the same way we've learned before, and the bad news is we can't just type these in our calculator. So let's take a look. So I've got, in this first example, all my bases are the same. They're all x, and they're being multiplied together. So my rule is to add up all the exponents. So a lot of people look at this and they do 9 plus negative 8 plus negative 2 is negative 1. But that is incorrect. Remember that x by itself has a little invisible exponent of 1 on this. So that entire problem actually, when I add up my exponents, ends up being x to the 0, and anything raised to the 0 except for 0 is equal to 1. So that answer is going to be 1 as long as x isn't 0. Next up, now we have some coefficients with numbers. Well, coefficients, those big numbers in front, behave like normal numbers. So if you look at just 16 over 2, divide that like you'd always divide it. 16 divided by 2 is just 8. Or if you think of simplifying a fraction, you can think of it as 8 over 1. But those numbers don't do anything different. They just do what they always do. Next up, I'm noticing this is not simplified because I have the same base repeating. You can't have the same base in one problem. It's not simplified. I'm noticing, though, the end of the negative fifth is the same thing in top and bottom. I can just cancel those out. They're the exact same thing, so as we've always done, if it's the exact same thing in top and bottom, cancel them out. And then all that's left is m to the fourth. So actually, that's my simplified answer, 8m to the fourth. You don't need a 1 in the bottom, although if you want to put it down there, that's absolutely fine. But just 8m to the fourth works out as an answer just fine. Bottom row, 10 over 2. As we just talked about, that just behaves like a normal number, so 10 divided by 2 is just 5 over 1. This time, be careful, your x's don't cross out. They're not the exact same thing top and bottom. One's x to the fifth, one's x to the negative fifth. So because they're being divided, we could do our subtraction rule, the top minus the bottom. I don't really like subtracting negatives, though. I like the elevator trick. So what I'm going to do is actually send that x to the negative fifth up to the top to make it x to the positive fifth. At this point, then, both x's are being multiplied together, so the rule is to add the exponents. So I end up with 5x to the 10th power. And finally on this screen, I have one term in that top parentheses. There's two parts of it, like there's x and y in there, but there's no plus or minus sign separating those, so I'm allowed to distribute the exponent. My rule is to multiply when I distribute exponents, so x to the negative 6 and then y to the positive 6. It's not distributed to the bottom because, well, that's not in parentheses. So x to the 5th and y to the 6th on the bottom. Now, once again, that answer is not simplified because I have the same bases repeating in the same problem. I'm noticing with the y's, though, they're the exact same thing, so I'll cross them out. Or think of it this way. If you did your subtraction rule with the y's, 6 minus 6, gets you 0, and y to the 0 is just a 1. So this part right here is basically just multiplying by 1, which won't change anything, so I'll just get rid of that. The x's, though, do need to be combined, and to make my negative exponent positive, I'm going to send that top one down to the bottom to make it x to the 6th power. Which means in the bottom, once I add up those exponents, I've got x to the 11th. That's not the answer, though. Remember, you can't have the bottom of a fraction with nothing written in the top, so make sure you throw a 1 up there. So it's 1 over x to the 11th power. And if you think you have the idea of exponents down after all those examples, this might be a great time to pause the video and try these 4 on your own. See if you can figure out how to simplify these using all the rules we've discussed. Otherwise, I'll talk through these and give you a few more examples, but probably best bet, pause the video, try some of these on your own. All right, so one term within the parentheses, there's no plus or minus sign separating those terms, so I am allowed to distribute my exponent. The rule for a power raised to a power is to multiply, so a to the negative 9th, and then b to the positive 12th. I can't have negative exponents. I don't consider that simplified. So anything negative needs to be moved down to the bottom of a fraction. Well, in a case like this, the a and the b are not attached to each other, so they can be moved individually. I don't want to move b to the 12th. That's good where it is. So I'm going to keep b to the 12th in the numerator just the way it is. That a, though, that a piece is going to move below this and become a to the positive 9th. So there's where my simplified answer is going to look like. I can move pieces individually just like that. Next example, bases are being multiplied together even though they're not right next to each other. I can switch them around if I wanted to. The rule is to add exponents when the same base is being multiplied. So I ended up with a to the 7th and then b to the negative 18th. Just like the last example, I don't want to have a negative exponent and I'm free to move pieces individually. So the a piece is fine the way it is. I'm going to leave a to the 7th in the numerator and move b to the 18th to the denominator to make it positive. Bottom row, I'd probably start with distributing that exponent into that parentheses. Again, it's only one term, so I'm allowed to do that. Now, where you want to be careful is people are pretty good at the exponent part, the variable part. They get it's going to be x to the negative 2nd when I multiply, and then y to the 6th power. But what they forget is everything is raised to the negative 2nd power, including that negative 2. If it helps, maybe throw a little exponent of a 1 on that negative 2. Ask yourself what that means. It's saying to do negative 2 times itself, which is going to get you a positive 4 for that piece in the front. People have a hard time with that, so maybe just make a special note about that, or if you tried it on your own, make sure you caught that. The first piece is just going to stay the same as it is. Then let's go ahead and multiply. I'd start with the coefficients, the big numbers. Nothing special happens with those. They do what they always do. 4 times 5 is always just 20. And then your exponents, find the ones that are the same base, and add your exponents together. So 2 plus negative 2 is 0. I end up with x to the 0, which is really just a 1, so you know what? Let's just get rid of that. And then finally, I have y to the negative third times y to the positive 6. I'll add those exponents together to get y to the third. And if I rewrite that a little neater without that x in there to the 0 power, there's my simplified answer. And one final one to take a look at. In a case like this, I like to go ahead and start with making one big fraction rather than having two fractions. I call it squishing, which I guess isn't a very mathematical word, but I like to do it, or use that word. So everything across the top is getting multiplied together. What's nice about multiplying fractions is you don't need common denominators. Just multiply straight along the top and bottom. So I'm going to put my coefficient in front. My x's are being multiplied together, so I'll add up those exponents since they have the same base. So x to the positive first power, and then y to the fourth would just remain the same. Along the bottom, multiply your coefficients first. So 2 times 6 gets you a 12 in front. X to the negative second's the only x piece on the bottom. I'm going to throw a 1 on that x on the top too. And then add up your exponents for the y pieces. That's going to be y to the negative fifth, sorry, once I add those up. Okay, it's not simplified because I do have the same base repeating, so I'll need to go through and do one more step to simplify this. The 3 over 12, I'm just going to simplify that right away to just 1 over 4, like you'd always do with fractions. Oops. So I have a 1 and a 4 as my coefficients. Your x pieces, let's see, I want to move that negative 1 up to the top. So that's going to become x to the positive second in the numerator. And once I combine those, it's going to be x to the third power when I add up my exponents. And finally, for my y pieces, I'll want to move that y to the negative fifth up as well to change it into y to the positive fifth. Once I combine those exponents by adding them together, I get y to the ninth power. And there is a very long video all about exponents. I'm sure it was very thrilling. Hopefully, though, it was informative. Hopefully, you tried a few of those on your own and were successful.